Greetings, YouTube. It finally got warm out. My windows are open. Today I'm going to review the God effect, quantum entanglement, science's strangest phenomenon with a category of time travel, teleportation, and the ultimate computer, written by Brian Clegg. If you know anything about quantum mechanics at all, one of the strangest features of quantum mechanics, at least in my opinion, is quantum entanglement. Now, quantum entanglement is often been described as spooky action at distance, because two halves of a particle will communicate in some way. We're not sure how they do this. At least I'm not, and I'm not sure that the author of this book does either. Information between them, regardless of how far apart they are. Before you say, well, that violates the speed of light and that violates physics stuff, they've tested this experimentally. So even if we don't understand the mechanism of the action, we've shown that it actually happens. This isn't something that is just a theory. This is something that we've experimentally shown does something in the real world. Essentially, when a particle splits, and this happens naturally all the time, though you can arrange under laboratory conditions to get a far more higher probability that you will get a split particle when you want one. So it is, again, can be done under laboratory conditions. That when a particle splits, the two halves go in opposite directions. And if you then measure something on one half of that particle, say its spin, and its spin isn't necessarily a physical motion, it's just a characteristic that scientists have called spin, and they usually refer to it as up or down. So say you're looking for spin, and you look on the particle that's gone to my left. We're just going to use directions because it's easier that way. When you measure for spin, you arrive at the spin. Boom, I checked it, that the half going to the left had a spin of up. That means that the half going to the right had a spin of down. And now, regardless of the distance between those two particles when you do this, that state will now exist. Before it had been complete theory. It had been complete uncertainty. Utter uncertainty. Not just, well, we're not sure, but actual uncertainty. All the different states existed within that particle, or half of the particle, and all the states existed in the other half of the particle. And as soon as you measured something, you collapse the probabilities down to a real-world thing. And the difference between these two, the up and down, or whatever other characteristic you're looking for, is communicated instantaneously between the two halves. This is an awesome thing. This is really cool. It's happening around us all the time. We just don't notice it because we're very macroscopic things. We're not microscopic things. Though we do benefit from the trait, because the thing you are looking on at me right at the moment, the computer, is all based on quantum mechanics. Without understanding quantum mechanics, we would not have solid-state circuits and such. I don't think there are many people looking at me on computers that aren't solid-state circuitry. If anyone out there is using a computer which is not solid-state circuitry, I want to know. Put it in the comments. That would be very cool. And this book deals with the very specific topic of quantum entanglement, that splitting I talk about, and how the two halves will then communicate with each other over any distance instantaneously. Spooky action at a distance, which is something that Einstein hated and spent the last half of his life trying to prove didn't happen, and he failed because it happens. Now, the one thing I did find a little annoying is the title of the book, The God Effect. Now, I found this book in the spiritual section because it was called The God Effect. Someone apparently just saw God and stuck it into the spiritual section, even though it deals with quantum mechanics, which made me smile. And it's one of the reasons I picked it up with The God Effect. I picked it up, and I saw quantum entanglement, and I'm like, that's not philosophy or spiritual, that's science. So I bought it. Because it's relating to the Higgs boson particle, which is often referred to as the God particle, because it is the reason that we have momentum. And because of that, without momentum, the universe would be far different. It probably wouldn't exist as we know it. We wouldn't be here. Cat. And they often refer to that as the God particle because it was so hard to find that the quest for it became so important. Now, linking these two terms, the God particle and the God effect, isn't necessarily a bad mechanism. But the author doesn't do it until the last 3 bloody pages of the book. I mean, there's no mention of the God effect for the entire book. He doesn't get around to mentioning it until the last 3 pages. I think he could have found a better title. Now, it wouldn't have been as eye-catching, I will admit that. But it could very likely have been more accurate to call it something else. What, I'm not sure. Now, the good thing is the author is very approachable. I really quite enjoyed how the author presented the argument, because it is a difficult topic. I mean, it's quantum mechanics. Quantum mechanics is never easy. He also has out Light Years, The Extraordinary Story of Mankind's Fascinated with Light. That one I'll probably look up. The First Scientist, The Life of Roger Bacon. I'll probably look that one up too. And A Brief History of Infinity, The Quest to Think the Unthinkable. I might read that one. I've read about infinities in the past. I found it interesting. Frankly, I read a book that dealt with doing math with infinities, which was probably just beyond my grasp of understanding. But that was back when I was like 20. So maybe at 49 I should reread something on infinities. So I'll be looking at other books by Brian Clegg. And I'll be passing this book on. I'll be donating this book because my wife's going to have absolutely no interest in this book. And I don't actually know anyone else in my circle of acquaintances that has any interest in a book about quantum mechanics. However, it was interesting. It was very descriptive. He does, in fact, talk about time travel. The idea that you can communicate, that there's nothing preventing us from using this to get a ping across time. Now, that's all you can be able to get with this information is a ping. You are not going to be able to transfer actual knowledge from one half of that particle to the other half of the particle. But you could get a ping. So you could be aware that something has happened. What's happened, you're not necessarily going to be aware of. But you could possibly use it as a ping over time. Talking about teleportation, that we've actually sung this. Scientists actually be able to move the characteristics of one particle group of gas particles, the largest group of things they've ever teleported, to another location that had the exact same characteristics. So they took a bunch of gas particles, copied their characteristics exactly, and then moved that information elsewhere at the speed of light, because that's the way it works, but speed of light still isn't bad. Now, that isn't necessarily actually moving the particles as physical objects, and not like they disintegrated them and make them new. They copied the information. So at the moment, that's the largest object we've ever moved from place to place, and it's very short, like across a lab, whereas gas particles. But that's an object. A cloud of gas is an object. So they actually moved an object from point A to point B. The characteristics existed here, and they made them move over here without crossing the intervening space in between, except with knowledge. And that's pretty cool. And then the ultimate computer, how quantum entanglement is going to be used as a major boost to security, as far as swapping security codes and things like that, using it as public keys, that's the term I'm looking for, and using the quantum entanglement to build faster, better computers, because we are rapidly approaching the wall of computer technology. There will be a point sometime, probably in the late 2030s and early 2040s, where we will hit processing power and we can't go any further. So there needs to be a change, and that's going to be a quantum computer if there is one. They're still working on that. And quantum entanglement is going to be involved in the creation of that quantum computer if they can ever pull it off. So, very good book, very approachable. It does help if you have some understanding of quantum mechanics. Even as a layperson, I don't know any of the math. Don't get me wrong, I'm claiming I'm not Einstein here. I don't get the math at all. But I do have some understanding of quantum mechanics because I've been reading about it for a couple of decades now. So I recommend you check this book out if you are interested in science, if you're interested in quantum mechanics on some level, even if it's tangentially. And if you want to have a better understanding of where the next step for computers and computer security is going to be in the future. Because I don't think there's any way we can avoid the fact that quantum mechanics is going to be involved both in security and the next generation of computers. I think that's just going to happen. It's going to have to. Otherwise, eventually, we're going to run out of processing power. You can only make circuits so small. You get to a certain point where you can't make them any smaller because electrons have to move from point A to point B. You get down below a certain point, there's no space for electrons to move. That's the problem. So, I recommend this book, even if it is mislabeled in my opinion. But I'll face it, the God effect, he's eye-catching.